It cannot corrupt the workflow without scope. Most organizations managing agentic AI today are doing it on static API keys and long-lived service account tokens, no expiry date, no owner, no audit trail that ties a specific action to a specific workload instance at a specific time. The 5-country guidance calls that an accountability gap. SPIFFE and SPIRE close that gap at the architecture level. An agent receives a cryptographically attested identity document at runtime, valid for 1 hour or less, automatically rotated, and bound to what the workload actually is, not what it claims to be. New Zealand's minimum cybersecurity standards Level 2 reporting cycle closed on the 30th of April 2026. The second cycle is already open. How many workloads in your environment are still running on credentials with no expiry date and no owner? Let's get into it. 6 allied governments published a joint advisory on agentic AI and listed privilege accumulation first. An agent cannot exfiltrate data without access. It cannot escape containment without credentials that travel farther than they should. This is the Hamberger report. I'm Andreas Hamberger, Enterprise Architect and Board Governance Practitioner, Wellington.
On the 1st of May 2026, 6 allied cyber agencies published a joint advisory on the careful adoption of agentic AI services. 30 pages, 5 risk categories, 6 governments aligned, and privilege was listed first. That ordering is deliberate. An agent cannot exfiltrate data without access. It cannot corrupt a workflow without scope. It cannot escape containment without credentials that travel farther than they should. Privilege accumulation sits at the top because it is the precondition for every other failure mode. This is the Hamberger report. I'm Andreas Hamberger, Enterprise Architect and Board Governance Practitioner, Wellington.
Human identity systems resolve authentication through a credential, a password, a certificate, a biometric token. The human exists before the credential is issued. The credential represents the human's authorization. The human remains accountable for what happens during the session. None of those properties hold for an AI agent executing autonomously. An agent workload is created at runtime. It may not have existed 5 minutes ago. Human identity systems resolve authentication through a credential, a password, a certificate, a biometric token. The human exists before the credential is issued. The credential represents the human's authorization. The human remains accountable for what happens during the session. None of those properties hold for an AI agent executing autonomously. An agent workload is created at runtime. It may not have existed 5 minutes ago. Its authorization derives from the task it has been assigned. Accountability for its actions must be traceable to the specific workload instance that took the specific action at the specific time, not to the human who deployed the agent system in general. SPIFFE addresses this by shifting identity from a credential-as secret model to a credential-as attestation model. Instead of issuing a long-lived API key, SPIFFE issues a SPIFFE Verifiable Identity Document at runtime, bound to the workload's attested properties, valid for a defined period, and automatically expiring when that period ends. The SVID is not a password, it is a statement. This workload running in this environment with these characteristics is authorized to act within this scope until this time. A SPIFFE Verifiable Identity Document takes one of 2 forms, an X509 certificate or a JSON web token. Both carry the SPIFFE ID, a URI identifying the workload within its trust domain. What makes the SVID secure is not that the identifier is hard to guess. It is that the identifier is cryptographically signed by a trusted certificate authority, short-lived, bound to the workload's attestation, and automatically rotated. A SPIFFE Verifiable Identity Document takes one of 2 forms, an X509 certificate or a JSON web token. Both carry the SPIFFE ID, a URI identifying the workload within its trust domain. What makes the SPIFFE secure is not that the identifier is hard to guess. It is that the identifier is cryptographically signed by a trusted certificate authority, short-lived, bound to the workload's attestation, and automatically rotated. Defaults with lifetimes in production run from 1 to 24 hours. Some implementations use lifetimes measured in minutes for high-sensitivity workloads. The practical consequence is significant. A compromised SVID provides access only for the remaining lifetime of the document. An attacker who extracts a short-lived SVID has a credential that expires in minutes or hours. An attacker who extracts a long-lived API key may have access for months or years, until someone notices and rotates it. The channel publishes daily. Next Friday's episode is the first episode of Lethal by Design, launching 26th of June. That series opens where this one leaves off. Accountability architecture at the boundary, where the agent pulls the trigger. Both series carry the same underlying governance question at different altitudes. SPIRE has two components, the SPIRE server and the SPIRE agent. The SPIRE server is the trust anchor for deployment. It manages the certificate authority that signs SVIDs, maintains the workload registry, and processes attestation requests. The SPIRE agent runs on every node where workloads execute. SPIRE has two components, the SPIRE server and the SPIRE agent. The SPIRE server is the trust anchor for a deployment. It manages the certificate authority that signs SVIDs, maintains the workload registry, and processes attestation requests. There is one SPIRE server per trust domain, typically deployed as a high availability cluster in production. The SPIRE agent runs on every node where workloads execute. It attests the node to the SPIRE server, then serves SVID requests from workloads on that node. When an AI agent process starts, it requests an SVID from the SPIRE agent on its node. The SPIRE agent verifies the workload's identity through node attestation and workload attestation, then presents the request to the SPIRE server. This is the critical architectural point. The SVID is issued based on what the workload is, not what it claims. The workload does not authenticate to SPIRE by presenting a secret. The SPIRE agent observes the workload's characteristics, its process identifier, its Kubernetes service account, its container image, its namespace, and verifies them against the registered entry. Identity is attested, not asserted. SPIRE cannot issue SVIDs to workloads it has not been told to expect. Every agent workload that will need a cryptographic identity must be enumerated, described, and registered before SPIRE can serve its identity needs. The defense and government sectors reached this conclusion for human identity decades ago. SPIRE cannot issue SVDs to workloads it has not been told to expect. Every agent workload that will need a cryptographic identity must be enumerated, described, and registered before SPIRE can serve its identity needs. The registry must stay current as agents are commissioned, updated, and decommissioned. The defense and government sectors reached this conclusion for human identity decades ago. The United States federal government's personal identity verification credential and the Common Access Card embed the same principle. Identity must be cryptographically verifiable per transaction, not assumed from network location or session. New Zealand's RealMe service applies the same principle to citizen digital identity. SPIRE is the workload identity equivalent of that principle for non-human actors. The defense and government sectors decided that human identity required cryptographic attestation. The agentic era requires the same conclusion for agent identity. The same principle that led the United States Department of Defense and allied government agencies to require cryptographic verification for every human access event now applies to every agent action. The standard exists, the implementations are production ready. What remains is the governance program, build the register, enroll it in a trust domain. Neither step is technically complex. Both require governance commitment, and both steps are now required before the next minimum cybersecurity standards reporting cycle. Most New Zealand organizations deploying SPIFFE and SPIRE will not be starting from a greenfield environment. They will be deploying SPIFFE alongside existing identity and access management infrastructure, Entra ID, Okta, AWS Identity and Access Management, or Google Cloud IAM. The primary integration pattern is federation. Most New Zealand organizations deploying SPIFFE and SPIRE will not be starting from a greenfield environment. They will be deploying SPIFFE alongside existing identity and access management infrastructure, Entra ID, Okta, AWS Identity and Access Management, or Google Cloud IAM. The primary integration pattern is federation. The SPIRE trust domain federates with the organization's cloud identity provider, allowing SPIFFE SVIDs to be exchanged for cloud-native credentials. AWS supports this through IAM roles anywhere. Azure supports it through Workload Identity Federation in Entra ID. Google Cloud supports it through Workload Identity Federation for GKE and external workloads. The practical result: an agent workload running in a Kubernetes cluster receives a SPIFFE SVID from SPIRE, then exchanges it for a short-term AWS IAM role credential, an Azure Managed Identity Token, or a Google Service Account key without any static secret ever being stored or transmitted. The federation step is automated. The static secret is never created. This is the protocol-level implementation of the 5 country guidances accountability category. If agent action cannot be attributed to a verified identity, the action must not execute, not a compliance checkbox. The technical precondition for accountability. The same SPIFFE and SPIRE deployment is consistent with requirements across 3 regulatory frameworks simultaneously. New Zealand Information Security Manual version 3.9 section 16.1 requires automated identity and access management governance. The same SPIFFE and SPIRE deployment is consistent with requirements across 3 regulatory frameworks simultaneously. New Zealand Information Security Manual version 3.9 section 16.1 requires automated identity and access management governance. The SPIRE's automated SVID rotation and lifecycle management address this requirement for non-human workloads. Manual secret rotation does not. Minimum cybersecurity standards level 2 requires asset metadata, configuration as code, and continuous drift monitoring. SPIRE's workload registry is configuration as code. The SVID issuance process generates per workload audit records. SPIRE's node and workload attestation mechanisms detect configuration drift by design. A workload whose container image has changed will not match its registry entry and will not receive an SVID. The EU's Network and Information Security Directive, Article 21, requires supply chain security measures, including identity and access management. SPIFFE cryptographic audit trails are aligned with that accountability intent for workload identity. 1 architecture pattern, 3 frameworks. The requirements converge because they are all responding to the same underlying gap, the absence of cryptographic identity verification for non-human workloads. What does your current agentic credential estate look like? How many workloads in your environment are running on static API keys, shared service accounts, or long-lived tokens with no expiry date and no owner?
That is the Hamberger report for today. If this was useful, subscribe and hit the like button. It helps more professionals find the channel. You will find links to everything we covered in the description below. I am Andreas Hamberger, and I will see you tomorrow.
Like and subscribe.